Okay, next thing. There are three types of sandwiches: turkey, ham, roast beef. Three types of sides: coleslaw, soup, and fries. How many meals can we create? Well, you have this. I have this written down. You don't. You don't have to. Okay, just watch. I can put my turkey with coleslaw, turkey with soup, turkey with fries. So there's three right there. I can order a ham sandwich with soup, with coleslaw, with soup, with fries. Roast beef with coleslaw, soup, and fries. So that's 9 possible meals. Now, rather than write all that crap, you can say, okay, I can pick one sandwich, but there's 3 to pick from. Write 3 down. I can pick one side. There's 3 of those to pick from, and 3 times 3 is 9. Okay? Okay. Now, turn the page, and there's some other stuff too, but we'll get to that. Okay. Actually, no, I want to go back to this. Okay. Chad, Martha, Thomas, and Enrique are in a 4-person race. How many orders are possible, 1st through 4th? Now, let's say Chad wins. He's the man. But then Martha could get 2nd, Thomas 3rd, Enrique 4th. Maybe Martha 2nd, Enrique's 3rd, Thomas is 4th. Maybe Chad's 1st, Enrique, Thomas, Martha. Chad, Enrique, Martha, Thomas. Chad, Thomas, Enrique, Martha. Chad, Thomas, Enrique, Martha. So that's 6 orders just there with Chad winning. Now, Martha wins, there'd also be 6, Enrique 6, Thomas 6. I don't need to write those out. But that's 6 plus 6 is 12, 6, and that's 24. Now, here's a quick way to get those answers, okay? It's using what's called a factorial. With factorials, you can take how many people are in the race, and you can find the total order of finish by putting an exclamation point on it. Now, that actually means in math factorial. And all that means you do is you can take 4 times 3 times 2 times 1, okay? And that's 24, okay? So we have that. Now, let's look at factorials, okay? So 5 factorial, that's 5 times 4 times 3 times 2 times 1, okay? And I just multiply that on my calculator. That's 120. Now 10 factorial. That's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Okay, I got 3,628,800. So if there's 10 people, you want to find out all the possibilities, every single possibility of 1st through 10th place. Could be the 9th and the 10th place switched around. That would be 3,628,800 possibilities. Now, if there's 3 people in the race, that's just 3 times 2 times 1, and that's 6, okay? Much less. Okay, now I want to go back here, and I want to take Chad, Martha, Thomas, and Enrique are in a 4-person race. How many 1st and 2nd place finishes are possible? So there's not going to be as many 1st to 2nd place finishes as there are complete 1st, 2nd, 3rd, 4th, because 3rd and 4th's been factored out. Okay, so Chad wins. Martha could get 2nd. I don't care about 3rd and 4th. Chad and Thomas, Chad and Enrique. Martha, Chad, Martha, Thomas, Martha, Enrique. Thomas, Enrique, Thomas, Chad, Thomas, Martha, Enrique, Chad, Enrique, Martha, Enrique, Thomas. Those are all just 1st, 2nd. Okay, now there ends up being 12, as you can see on your paper. But the quick way to get that is what's called a permutation, okay? Permutation is when there's might be 4 people in a race, but I don't care about all the places, just some of them. What I do is I put a big P out here. There's 4 people, I put that, and I just care about 2 finishes. So how many finishes wouldn't I care about? Well, 4 minus 2 is 2, so 2 minus those 2. Now, in a permutation, you cross that out because I want to leave those 2 alone. So what I do is I write 4 factorial, but I'm going to divide it by 2 factorial. So what I do is I take 4 times 3 times 2 and stop, because you're going to divide out the 2 factorial, because that's on bottom here. And 4 times 3 is 12. Okay, just what I got. Okay, so on my permutation, I go to this paper. So if I have 9 people in a race, I want to know how many first, second, third possibilities there are. That leaves 6 I don't care about. Now I cross out the 3 because I don't want to mess with them. So 9 factorial over 6 factorial. So I go 9 times 8 times 7 times stop at 6. And then we can cancel those, and really it's just 9 times 8 times 7. I don't actually end up dividing even though you see a line. It cancels out. So it'd be 504 possibilities. Okay, that's how you label these permutations and factorials. I should have been putting possibilities on these, but I didn't. Okay, 8 people. I want to know how many combinations, first, second, third, fourth, fifth. So there'd be the 3 at the end I don't care about. They're losers. You factor out the losers. 8 times 7 times 6 times 5 times 4 times 3, and the 3's cancel. So I take 8 times 7 times 6 times 5 times 4. 6,720 possibilities. Okay, there's 11 people in a race. How many people, how many first, second, third, fourth could you have? Well, there's 7 that you don't care about, so you need to factor out the 7 losers, loser scum. 11 times 10 times 9 times 8 times 7. Now the 7s are canceled. And I take 11 times 10 times 9 times 8, 7,920 possibilities. Okay, now we're going to apply some of this stuff to some word problems. You don't do the same thing on every problem, though. A license plate is made up of 4 letters and 3 digits. How many different license plates are possible to create? Now keep in mind we have 26 letters to pick from and 10 digits. So when I pick letters, I have 26 to pick from. It's kind of like that sandwich problem, but instead of picking 1, you have to pick 4 letters, okay? So I write 26 down. And that would be to the 4th power because we need to take 4 of them. Times, and then I need to pick my digits. How many digits do I have to pick from? I have 10. I need 3 of them, so to the 3rd power. Okay. So I just find out what 26 to the 4th times 10 to the 3rd is. So that's quite a few, as you can see. 456,697,000, or 976,600. Okay, now that's quite a few. That's more people than live in the U.S. altogether, and that's why everybody's able to have their own numbered license plate. Okay. Now, the reason you didn't use powers on the sandwich is because you're only able to pick 1. Okay, so it's just 3 times 3. Now, if I have 2 sandwiches, it'd be 3 to the 2nd times 3. 3 sandwiches on a side, 3 to the 3rd times 3. Again, I'm picking there's 26 digits, there's 26 letters to pick from, but you pick 4, so to the 4th power. And there's 10 digits to pick from, but you're picking 3, so times 3. You repeat the multiplication, and the reason why is because when I pick my first letter, 26. When I pick my second, 26. To pick from. When I pick my third, that's 26 to pick from. When I pick my fourth, that's 26. That's why it's to the fourth power. When I pick my letters, or numbers, that's 10. Second digit, 10. Third digit, 10. Okay? So that's how you get the powers on those things. Okay, there are 4 people in a race. How many ways are possible for them to come in first through 4th place? Now, with these places, I'm going to write the words have and take. Okay? Now, I have 4 people in the race. How many am I going to take? Well, it's first through 4th, so I take all. So when I'm finding all the places, that's 4 factorial. Okay? So that means 4 times 3 times 2 times 1, and that, as we saw, is equal to 24. Now, there are 12 countries in the medal round of U.S. hockey. How many ways are possible for countries to finish first, second, third? So, again, I have 12, but I'm only going to take 3, okay? And those 3, I see first, second, third, so they're being ranked. So I could get Germany, France, and Belgium, but then I could go Belgium, France, Germany. I can get a bunch with just those 3. So when I rank them, but only some of them, not all of them, only some of them, that's using a permutation. Okay? 12, I'm going to rank 3. I am not going to rank the last 9. So we don't want to mess with the 3, because I need to divide out the losers. Okay? I don't want to rank all 12. I want to cancel out the ranking of 9 of them. So 12 times 11 times 10 times 9. Stop. Okay? And we factor out the 9. Okay? So 12 times 11 times 10. Another way, 1,320. There's a bunch of ways you can think about it. Like when we start, 12 countries can get first. Now, if I take the first place, then there's 11 more countries that could get second. And then they're gone. And then that leaves 10 more that can finish third. Okay, next one. A Quiz Bowl team must have a freshman, a sophomore, a junior, and a senior, one of each. There are 61 freshmen, 50 sophomores, 60 juniors, and 45 seniors in school. How many possible teams can be created? Okay. Okay, so with that being said, I need 1 freshman. How many freshmen are there? 61. You don't put it to a power because you're only picking 1 of them. If there were 2, it'd be to the second power. Okay, I need 1 sophomore. I have 50, but that's just to the first power because you can only take 1 of them. Okay, I need 1. It's when you have groups of things that you can pick 1 of each. This is where you just pretty much multiply. Okay, juniors, I have 60 of those and 45 seniors. So that's going to be to a lot of possibilities. So 61 times 50 times 60 times 45. That is 8,235,000. Okay, there are 15 people running the mile. How many ways can the competitors finish a race in places 1st through 15th? So again, I have 15. I want to take all of them because it's 1 through 15. So that's 15 factorial. Now, you can go 15, but there's another thing you can use on these calculators. You can put PRB here. That means you punch in 15. You can hit PRB and then hit your side arrow, go to the exclamation point, and it'll find it for you. That's such a big number, it's in scientific notation. Okay, so I write it down. 1.307674368 times 10 to the 12th power. Okay, it's such a huge amount. There's so many possibilities a calculator can't even hold it as to express it in scientific form. Okay, there are 50 golfers at the state meet. In how many ways can the competitors finish in 1st, 2nd, and 3rd? Okay, so I have 50. I'm not taking all the places, just 3. And those 3 are first, second, third. So like Jenna Snyder, Aaron Locke, and Annika Patton, I go Jenna, Erica, Annika. I go Annika, Aaron, Jenna, okay? I can also have Aaron win and flop the last 2. There's a bunch of different ways I can do with just those 3 people, but they are ranked, okay? So that is the permutation. So 50, 3, and 47. Now, we want to not use that 3 because I want those people ranked. Okay? If you want those people ranked, don't put them in the expression. So 50 times 49 times 48, and then the 47s can cancel. So really it's just 50 times 49 times 48. I don't go past the 48. Okay, so 117,600. Seems impossible, but if I made you sit down and list it, you'd agree with me that, oh yeah, it probably is that much.